Let's solve few problems based on the previous concept, whatever we have learned. Look at the first one. Two cards are drawn at random and without replacement from a pack of 52 playing cards. Find the probability that both the cards are black. Right? So here, it's a very simple type of problem. See, probability of the first one being black. Let's say PB1. So in total there are 26 black, correct? Out of 52. So we have 26 out of 52. That's nothing but 1 by 2. Okay. Now probability of B2. Now first thing you need to understand that once you pick a card, the second black card has no relation to whatever the first card is going to be, isn't it? So if there is no relation, that means it has to be an independent event. If it's independent, it's very easy. You just have to multiply, correct? So P of B1 is this, and P of B2 is going to be 25 out of 51, correct? So what is P of B1 intersection B2? That both of them are there. So 1 by 2 into 25 by 52. So 25 divided by 102. That's it. That's the answer for the first one. Fair enough? Now let's do the second one. Look at the second one. A die marked 1, 2, 3 in red and 4, 5, 6 in green is tossed. Let A be the event, the number is even, and B be the event, the number is red. Are A and B independent? So first let's write down what is there, what is not there. See, we have a die is marked in such a way that 1, 2, 3, this is in red, correct? So for this second question, we can say that event A is nothing but, let event is, the number is even. How many even numbers are there? 2, 4, 6, correct? And event B is what? Event B is basically, you are going to write, so event B is the number is in red, correct? So we have the numbers in red are what? 1, 2 and 3. Make sense? So probability of A is going to be 3 out of 6. That's 1 out of 2, correct? There are 3 even numbers out of 6 numbers in a die. That's going to be 1 by 2. Likewise, P of B is going to be 1, 2, 3. That's 3 out of 6. That's 1 by 2. So the question is, are A and B independent? See, if it has to be independent, then A intersection B should give us P of A into P of B, correct? So first let's try to calculate A intersection B. A intersection B is 2, correct? So we are going to get P of A intersection B, P of A intersection B is equal to 1 out of 6, because one number is common, right? So P of A intersection B, we know P of A intersection B, this is 1 by 6. P of A and P of B, P of A into P of B, 1 by 2 into 1 by 2, that's 1 by 4. They are not the same, correct? So what can we say? Therefore, A and B are not independent. So when we say they are not independent, please remember this is the keyword. Not is the keyword. Clear? This is the answer for the second one. Let's do the third one. Look at the third one. Given that events A and B are such that P of A is this, so let's write it down. P of A is equal to half, P of B is equal to P, P of A union B is equal to 3 by 5. Correct? Find P if they are mutually exclusive. Alright, see, if they are mutually exclusive, then the intersection is 0, correct? So we can say that P of A union B is equal to, okay, so I'm doing the first sub question, that is the mutually exclusive part. P of A union B is equal to P of A plus P of B minus this intersection B, correct? Now, what we do know is that this value is going to be 0 because A intersection B is a null set for mutually exclusive. Now, P of A union B 3 by 5 is equal to 1 by 2 plus P of B is P, isn't it? So, if you want to find the value of P is equal to 3 by 5 minus 1 by 2, correct? So, this is going to give us 10 is the LCM, 6 minus 5, that's 1 out of 10. So, P value is going to give us 1 by 10. Make sense? So, this is the value of P. This is the answer when the two events are mutually exclusive. Now, we'll do for the independent event, right? For the independent events, see, P of A intersection B is nothing but P of A into P of B, correct? This is what we have. So, we can say that this is half into P, or we can directly say P by 2. Again, we are going to use the same formula, that is P of A union B is P of A plus P of B minus P of A intersection B. We'll make use of the same formula, no change. Substitute 3 by 5 half plus P minus P by 2, because A intersection B is P by 2. So, if you take this one, we'll get 3 by 5 is equal to half plus P by 2, correct? Now, see, you can take LCM in the RHS and directly do it, or you can do any math you want. So, here P by 2 is equal to 3 by 5 minus 1 by 2. See, 3 by 5 minus 1 by 2 just now we did, that's 1 by 10. 1 by 10. See, if P by 2 is 1 by 10, then can we say therefore P is equal to 1 divided by 5. So, this is the answer for the third question, that is 3B, the second part of it. Fair enough? Now, let's do the next one. See the fourth one. If A and B are two events such that P of A, P of B and P of A intersection B is given, find P of not A and not B, correct? So, when we talk about not A and not B, first P of A 1 by 4, P of B 1 by 2, P of A intersection B is equal to 1 by 8. So, P of not A and not B, that's basically P of A complement intersection B complement, or we can also say 1 minus P of, okay, so we'll look into the De Morgan's law part later, but for now we can just look into this one. Okay, see, we know P of A intersection B, correct? From this we can calculate P of A union B. See, P of A union B becomes P of A plus P of B minus P of A intersection B. See, this basically is P of A complement intersection B complement. Okay, so this is going to be P of A is 1 by 4 plus 1 by 2 minus 1 by 8. 8 is the LCM. So, you are going to have 2 plus 4 minus 1. 6 minus 1 is 5. 5 by 8. So, P of A union B is this. That is the same as P of A complement intersection B complement, which is 5 by 8. So, this is what we call as the De Morgan's law. So, we have understood this in sets, the first chapter, sets and relation. There we had discussed about De Morgan's law and what it is and how it is done. So, we are going to use the same concept in probability, because if you think about it, set A and set B and A intersection B, they are all sets, correct? So, we can use all the laws of whatever we have learnt in sets to apply in these kind of problems. Make sense? Let's do the next one. See the fifth one. given two independent events A and B such that P of A is 0.3, P of B 0.6. Alright, so we have a lot of things to calculate. See the first one, P of A and B, that's intersection. P of A and B. Since it is given to be independent, please look at these words, independent events, very, very, very important. Right? So P of A intersection B or P of A and B, since they are independent, P of A into P of B. That's 0.3 into 0.6, 0.18. This is answer for the first one. Very simple. Look at the second one. So P of A and B complement. First, let's do P of B complement. For that, P of B complement is 1 minus P of B. That's 1 minus 0.6, 0.4. Right? Since it is 0.4, this is going to be P of A into P of B complement. That's 0.3 into 0.4, which is 0.12. Fair enough? See the third part? See, when you look at the third part, it is P of A union B or B, correct? That's P of A plus P of B minus P of A intersection B, isn't it? So, which is 0.3 plus 0.6 minus 0.18, right? Which is 0.9 minus 0.18. So 0.9 minus 0.18, this is going to be 0.72. This is answer for the third one. Now the last one we'll do, the fourth one. See the fourth one? Neither A nor B. So you can write this as P of A union B complement. So 1 minus P of A union B, isn't it? So this is going to be 1 minus 0.72, just now we did it. 1 minus 0.72, this is going to be 0.28. So answer is 0.28. Clear? Let's do the next one. See the sixth one. Two balls are drawn at random with replacement from a box containing 10 black and 8 red, isn't it? So number of black is 10, number of red is 8. So total is going to be 18, isn't it? So probability of a black one is 10 by 18, or you can say 5 by 9. And probability of red is 8 by 18, or you can say 4 by 9. So we have 5 by 9 and 4 by 9. This is the probability. Alright, look at the first one. Now both the balls are red. So P of both red. Since they are independent events, so first probability is going to be 4 by 9. See, since this is with replacement, you take the red ball out, okay, you look at it, you put it back again and you mix again. Now the number of red balls are the same, correct? That's with replacement. So again, when you're picking the red ball, don't you think the probability will be the same? Because you pick it, you put it back. So the number of balls is the same. It's not going to change. So 4 by 9 into 4 by 9. That's 16 by 81. Fine. Second one. First one is black. Second one is red. So probability of black and red, or can we say black and red here, isn't it? So probability of black is 5 by 9 into 4 by 9. That's 20 by 81. Fair enough? Now the third sub question. One of them is black and the other is red. See here, there is no specification as to which one is black, which one is red, isn't it? So one of them is black, other is red. So we can have two cases. Probability of black and red, or probability of red and black. Correct? So the first case is going to be 5 by 9 into 4 by 9 plus 4 by 9 into 5 by 9. That's 20 by 81 plus 20 by 81, which is 40 by 81. Fair enough? These are the answers for this particular question. So whatever the problems we have done so far, they're all related to independent events, correct? So in the next video, we'll look into the next concept what you have in probability.